Good afternoon. My name is V. Pradeep Reddy and my roll number is 2095182151 and I am from Aeronautical Engineering branch and subject rocket and missile technology. TikTok topic is NASA lifts up metal 3D printing to new heights. NASA lifts metal 3D printing to new heights. One small step for NASA, one big leap for metal additive manufacturing. That's the upshot of a metal 3D printing technique NASA's Robotic Deposition Technology team and Aerojet Rocketdyne, a commercial liquid rocket engine builder, recently incorporated that could help to decrease the cost of engine components and lead times by up to 50%. For the first time, NASA incorporated and successfully tested a technique called cold spray deposition on one of its engine components. In this case, CSD was used to add a protective jacket of NASA's HR1 material, a nickel-based alloy that resists corrosion, oxidation, and embrittlement in extreme environments, to the exterior of a combustion chamber for the 7,999 pound class of lander engine that Aerojet Rocketdyne is building in partnership with the agency. By passing the rigorous hot fire test, which simulates the extreme environment of a working rocket engine, NASA essentially proved the use of CSD in manufacturing engine components. That approval allows builders of critical components to confidently add CSD to their metal AM toolboxes. NASA innovators recently developed a new metal alloy using a 3D printing process that dramatically improves the strength and durability of the components and parts used in aviation and space exploration, resulting in better and longer lasting performance. NASA alloy GRX 810, an oxide dispersion strengthened alloy (ODS), can endure temperatures over 2000 degrees Fahrenheit, is more malleable, and can survive more than 1000 times longer than existing state of the art alloys. These new alloys can be used to build aerospace parts for high temperature applications like those inside aircraft and rocket engines, because ODS alloys can withstand harsher conditions before reaching their breaking point. The nanoscale oxide particles convey the incredible performance benefits of this alloy, said Dale Hopkins, Deputy Project Manager of NASA's Transformational Tools and Technologies project. It's challenging and expensive to produce ODS alloys for these extreme environments. To develop NASA alloy GRX 810, agency researchers used computational models to determine the alloy's composition. The team then leveraged 3D printing to uniformly disperse nanoscale oxides throughout the alloy, which provides improved high temperature properties and durable performance. And cleaner than conventional manufacturing methods. Impacts and benefits of GRX 810 alloy. These alloys have major implications for the future of sustainable flight. For example, when used in a jet engine, the alloy's higher temperature and increased durability capability translates into reduced fuel burn and lower operating and maintenance costs. This alloy also affords engine part designers new flexibilities like lighter materials paired with vast performance improvements. Designers can now contemplate trade offs they couldn't consider before without sacrificing performance. Breakthrough performance, a revolution in materials development. NASA's new alloys deliver enhanced mechanical properties at extreme temperatures at 2000 degrees Fahrenheit. GRX 810 shows remarkable performance improvements over current state of the art alloys, including twice the strength to resisting fracturing, 3.5 times the flexibility to stretch bend prior to fracturing, more than 1000 times the durability under stress at high temperatures. Discovery of the GRX-810 alloy. The team applied thermodynamic modeling and leveraged 3D printing to develop the new high temperature alloy that delivered this breakthrough performance. Applying these two processes has drastically accelerated the rate of our materials development. We can now produce new materials faster and with better performance than before, said Tim Smith, and material research scientist at NASA's Glenn Research Center in Cleveland and one of the inventors of this new alloy. What used to take years through a trial and error process and now takes a matter of weeks or months to make discoveries, added Hopkins. Using thermodynamic modeling, one of the many computational tools discussed with the NASA 2040 vision study, the team discovered the optimal alloy composition after only 30 simulations. This modeling tool produces results in much less time and with lower cost than traditional trial and error processes. The tool also avoids dead ends by showing researchers not just what metal types to incorporate, but how much of each element to infuse into the composition. The performance of this alloy clearly demonstrates the modeling tool's maturity and ability to produce significant results, said Steve Arnold, Materials and Structures Technical Discipline Lead at NASA Glenn. 3D printed metal at NASA Glenn Research Center. NASA looks to advance 3D printing construction systems for the moon and Mars. The process of building landing pads, habitats, and roads on the moon will likely look different than the common construction site on Earth. Excavation robots, for one, will need to be lightweight, yet capable of digging in reduced gravity. A large-scale construction system could be autonomous and equipped to work without astronauts' help. As part of the Artemis program, NASA has a concept for the core surface elements needed to establish a sustained presence on the moon, which emphasizes mobility to allow astronauts to explore more and conduct more science. NASA is considering putting in place a lunar terrain vehicle, habitable mobility platform on lunar orbit, and surface habitat on the moon by end of the decade. The agency is investing in advanced manufacturing, one of the five industries of the future, to enable space exploration and improve life on Earth, including technologies that could find and use available resources on the moon and Mars to build out future infrastructure. Help in space. As we can see, the setup of infrastructure may look like this on moon. Help in space. Today, NASA is working with ICON, a construction technologies company based in Austin, Texas, on early research and development of a space-based construction system that could support future exploration of the moon and Mars. The company has 3D printed communities of humus and structures on Earth and participated in NASA's 3D printed habitat challenge, demonstrating a construction method and technologies that may be adaptable for applications beyond our home planet. Since the 1960s, the NASA Marshall Space Flight Center has been in the charge of some of the most renowned outer space missions in history, from the Hubble Space Telescope to the Apollo missions. Now the NASA Center is attempting to fully develop a Space Launch System (SLS) program, which entails manufacturing heavy lift launch vehicles able to carry both human astronauts and specific lab equipment to new horizons. Thank you.